Unit 4, Lesson 2, Keeping the Equation Balanced. Here we are starting with a notice and wonder with hanging socks. You can see colors on the screen that you can't quite see on your paper. That might be helpful as you're describing things that you notice and things that you wonder, but I want there to be quiet time right now. 60 seconds, what are some things that you notice? Write them down. Pause the recording, give yourself 60 seconds, write down what you notice. Now that you've taken 60 seconds to notice and write down, now I want you to continue to look at that image. What are some things that you wonder? What questions do you have based on this image? 60 more seconds, pause the recording, give yourself another 60 seconds. All right, now let's start sharing some things out. What do you notice? Charlie. Yes, this right hanger is uneven. What do you notice, Luke? Okay. So let me just make sure I understand. You said these ones are the same length, but when we're looking at this one, we can see that this one is longer. Okay. So pink socks are the same size. Blue socks are a different size. Anyone else notice anything else? Block socks. Blue socks, different sizes. What else do you notice? Is that Daxton's hand? Daxton. They are on hangers. Last one, Sam. Yeah. Closet's empty other than the socks. What do you wonder? Do you wonder who the heck hangs their socks? Yeah. Why is your closet full of only hanging socks and nothing else? Yeah. Who hangs their socks? What else do you wonder? Tage.
So it looks like the right sock is dirty with the blue and the left sock's clean, and the left sock with the red's dirty and the right one's clean.
Man, that's a lot of detail that you can pick out from a picture. Is it just because of like the shadows and the shading and stuff that you see? Okay. So you're wondering if the socks are... Okay. Lance? Yeah, exactly. Daxton. Okay. Left blue sock, is it wet? Why is that something that we might wonder? What are some things that we notice that make us wonder that? Maverick? Yeah, it looks like it's longer and stretched out a little bit. Yeah. Tage? And yeah, it's tilting it. It's one of those things that we notice. The blue socks are uneven. So why is it uneven? Why is this one pulling it down? We can wonder that. Is the left sock wet? Or even just why is it unbalanced? And then we can start wondering, is it unbalanced because the left sock is wet? Is it unbalanced because there's something in the toe of the sock stretching it out and pulling it down? Is this one dry, making it weigh less? So all good things to wonder. And now we have 2.2 hanging blocks. This picture represents a hanger that is balanced because the weight on each side is the same. We saw this with our warm-up. Those watching the video, sorry, I did not record the warm-up. But we can see that this is balanced. The weight on each side is the same. Elena takes 2 triangles off of the left side and 3 triangles off of the right side. Will the hanger still be in balance, or will it tip to one side? If it tips to one side, which side? Explain how you know. And then I also want you to move on to the next one after discussing that. If a triangle weighs 1 gram, how much does a square weigh? Talk with your groups and see if you can figure that out. We'll come back together in about 60-ish seconds. Pause the recording and give yourself time to work on this. Ready, set, go. Is it still going to be balanced when Elena takes off 2 from this side and 3 from this side? Okay, how do you know that it's not? Thank you for the hands. Honors class, there should be more hands. Still more. Thank you. Is that Gracie over there? Yeah, Gracie. Perfect. Yeah, perfectly said. It's even right now. So if I'm taking off different amounts, then it's going to make it uneven. So let's answer this question then. Or let me write that down. Which side is it going to tip to? If we know now it's going to be unbalanced, which side is it going to tip to? Caden. Why will it tip to the left? It's hard to explain, isn't it? All right, give it a try, Fitz. Well, we don't know that yet. Don't jump ahead to that part yet. We'll get there in a second. Without knowing how much it weighs on each side, how am I going to figure out which side it's going to tip to? Danielle. Yes. So less weight taken off, and this is more weight taken off. So even though it's more weight taken off, why is it not going to tip to the right? It's right there in that answer, right? It's more weight taken off, which means it has less weight still there. And so yes, it is going to be unbalanced. It is going to tip to the left based on that description that we just got from Danielle. Tip to the left because it will weigh more. Some of the things that I want you to take away from this lesson, and we're going to address them in the summary. You may or may not have realized that all the times that we solve equations, I'll say is equal to and balanced with. I don't just say is equal to. I say is equal to and balanced with, because I always envision this sort of hanging scale or one of those balance scales where it is balanced and it's equal. And so when we're doing something, we need to make sure that we do the same thing to both sides. So if a triangle weighs 1 gram, that means this triangle right here is 1 gram, and this triangle is 1 gram, and this, and this, and this, and this, and this are all 1 gram. How in the world does that help me figure out how much a square weighs? Talk me through that process. Did anyone else besides these two hands make it that far? Okay, then we're going to pause recording and give you another chance to work through that, because it is possible to figure it out. So with your groups, work through that. Pausing the recording, ready, set, go. Triangles each weigh 1 gram. So how can I figure out how much a square weighs based on that information? Let's call, I haven't called on Brock yet today. Brock. Good. Notice what he said. Took away a square from each side, keeping it equal and balanced. Whatever I do to one side, I do to the other side. Keep going. Good. Take away 2 triangles from each side. Whatever I do to one side, we do it to the other side. Keep going. Good. Because we know, just like on our warm-up, we know that these 3 triangles, I did call on you on the warm-up, huh? I remember now. Yeah. These 3 triangles weigh 3 grams, which means this side has to be the same because it's equal and balanced. So this also has to be 3 grams, which is why Brock's next step is very logical. We have 3 grams split among these 2 shapes. 3 divided by 2 means each one of those would have to be 1.5 grams. And again, showing my work just by scribbling these things out, showing that these are all 1, showing that that totals to 3. It's balanced with this 3. That's enough work to show for that type of problem. Next one. More hanging blocks. You have 2 different problems here. A triangle weighs 3 grams and a circle weighs 6 grams. So even though they're 2 different hangers, that same information works for both hangers. Find the weight of a square in hanger A and the weight of a pentagon in hanger B. And then I want you to write an equation to represent each hanger. think about our chocolate problems. We wrote equations for the chocolate problem, so you can write equations here as well. With your groups, ready, set, go. Pause the recording now. All right, a triangle is 3 grams, so I'm going to go ahead and label that triangle 3, even these ones over here 3. Circle is 6 grams, so I'm going to label this 6, 6, 6, 6, 6, 6, and 6. And to solve, just like the last one, I can see, wait a second, I've got a circle on each side. Can we go ahead and just get rid of that circle? Yeah, I've got a square on each side. I'm going to go ahead and get rid of the square that's the same. What does this side now weigh? 6 plus 6 plus 3 is a total of 15, which means this side is also a total of 15, but it's split among 4 shapes. So 15 split among those 4 shapes means that each square is 3.5 grams, yes? All right, nicely done. 3.75. That is correct. Yep, no, you're right. I'm sorry. 3, not even 0.75. 3.75 grams. Okay. B. I heard some really good conversations. This one, since I did A by myself, B, I'll open it up for discussion. Emma, get us started. On each side, I hope, right? Okay. Good. Exactly right. So let's back up just a step. Let's not get rid of these just so that we can see that infinite solutions a little bit easier. We reach this point where we can't take away any more circles. We can't take away any triangles, but I do see that a circle weighs 6, just like 2 triangles weigh 6. So I can take away 2 triangles at the same time that I take away a circle because they have the same value. I'm still taking away 6 from each side, so it's still balanced. And now I'm left with 2 pentagons is equal to 2 pentagons. Does this bring back reminders of 2 tubs of chocolate equals 2 tubs of chocolate? Yeah, so what is the weight of a pentagon? Anything. Anything. Now, I also want to be able to write equations to represent each hanger. Those can get pretty messy, so I want to focus just on hanger A. And I'm going to go back to the beginning. We have 1 triangle plus 2 circles plus 1 square plus 1 more circle, which is equal to and balanced with 4 squares, 1 circle, and 1 square. That's the equation in its exact form, exactly as we see it. But of course, there's some simplifying that we can do, right? Why are we talking about 3 circles in 2 different places? We can really just combine our circles together. We would have 3 circles, just like we can combine our squares together over here. And instead of talking about 5 squares in 2 different places, we can talk about just 5 squares. So I hope that this brings back some memories of simplifying before we start to solve. This is that equation. We also can make some substitutions because I know it was given to me that the triangle was 3 and the circle was 6. So if I wanted to, I could even then substitute. So C is 6. So I have 3 times 6. For the sake of time, you're okay if I just say 18, right? 3 circles would be 18. 1 triangle would be 3. I'm sorry. Will this be better if I do that? Okay. 3 plus 18 plus 1 square is equal to 5 squares plus 1 circle, which is 6. I'm just making those substitutions. And one last thing that we could do to simplify 3 plus 18 is 21. So I have 21 plus S is equal to 5s plus 6. Do you realize that this equation, from the very beginning, can simplify all the way to that? Also understand that this crazy, long, complicated one, you already solved. You solved it using the hangers and the images and that thought of just doing the same thing to both sides. One thing that's new in this lesson that we haven't really seen before is we have a variable on each side. So again, we aren't going to be able to make flow maps for these types of equations, but it doesn't mean it's unsolvable. We were already able to solve it. We started solving it by taking away a square from each side. And when I take away a square from each side, 5 squares take away 1 square, leaves me with 1 square left. And now this looks like any other equation that we've solved. So I just kind of want to give you a preview into what we're going to be seeing in the coming lessons. I really, really like the Are You Ready for More? So I want to make sure we have enough time for the Are You Ready for More? Which is next. What is the weight of a square on this hanger if a triangle weighs 3 grams? Talk with your groups. What is the weight of a square if a triangle weighs 3 grams? I'm going to have to cut you off after 90 seconds for the sake of time. So pause the recording, give yourself 60 to 90 seconds. Ready, set, go. Up. A triangle is 3 grams, so 3, 3, 3, 3, and 3. Right? But before we even do that, I hope that you realize, hey, wait a second, I've got 2 triangles here and the same 2 triangles here. We can get rid of those, right? And I have a square here and the same square over here. What do we do now? It's not a lie. Sam. It does have to be equal. Yep, you got it. So, that was a great description. He says we have an unknown number, which I used x, plus 3, which is equal to 0. Is this solvable? Yeah. Now, let's tie it all back in. Is it possible? No. Is it mathematically possible? Yes. So I do want you to understand this isn't a no solution. Mathematically, we do have a solution, and that solution is the square has to weigh negative 3 grams. Now, is it possible for something to have negative weight? No, which is why it's not possible with an actual balanced hanger, but mathematically, there is a solution. It is not possible for something to weigh negative 3 grams, but mathematically, there is a solution. Does that make sense? Okay, it's time to summarize. Lesson 2 summary. When we get to the summaries, we highlight, so quietly get out your highlighters. I'm going to continue on as if you already have it in your hand. We have equal weights on the ends of a hanger, then the hanger will be in balance. Whoa, 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 I said quietly. That is definitely not quiet. Try that again. If there is more weight on one side than the other, the hanger will tilt to the heavier side. We can think of a balanced hanger as a metaphor for an equation. This is a question on your test that not many students got correct. An equation says that expressions on each side have equal value. A lot of you on your test did not correctly explain the difference between an expression and an equation. Just like a balanced hanger has equal weights on each side, expressions on each side would be equal. So here's an example. If we have a balanced hanger and add or remove the same amount of weight from each side, the result will still be in balance. So I have a square plus 2 triangles is equal to 5 triangles, or A plus 2B is equal to 5B. But if I just get rid of this 2 triangles here, as long as I get rid of the same 2 triangles on the other side, it still is going to be in balance. Mathematically, that's minus 2B from each side. And that means I'm left with A is equal to 5B minus 2B is 3B. We can do those same moves with equations as well. Adding and subtracting the same amount from each side of an equation maintains the equality. So the same moves that I can do with a hanger, a balanced hanger, we can do with an equation. We can add things or take away things as long as we're doing the same thing to each side. And so here is your cool down. Here is the hanger that is in balance. We don't know how much any of its shapes weigh. How could you change the number of shapes on it, but keep it in balance? One thing that you could do that most students don't even think about, I could decide to add a pentagon, as long as I also add a pentagon to this side. The same type of looking pentagon. As long as I'm doing the same thing to both sides, that's going to work. Most students don't think of that. Instead, what we probably jump to is, hey, let's get rid of what they have in common. And I like that way of thinking better. They have 2 circles. I'm going to get rid of the 2 circles. I'm changing that hanger, but still keeping it in balance. And I've got 2 squares here. I have the same 2 squares on the other side. So if I get rid of them from both sides, it is still going to be in balance. It says draw a new diagram. I think just scribbling out those is fine. Yes, Fitz. Yes, at this point you can then start making conclusions, and what you're describing is not just adding or subtracting. What you're describing is dividing. But yes, that is still possible. We can see that 1 square would be the same as 2 triangles. Nicely done. Your homework is the 8.4.2 practice problems. So grade 8, unit 4, lesson 2 practice problems. More balanced hangers. Okay. You can skip, let's see. Which ones do I let you skip? You can skip number 5 just because we have not yet covered that material. So skip number 5. If you want to give it a try, you're welcome to. But I'm not requiring that. But 1 through 4 you need to do. The other thing I would like to draw your attention to is our warm-up came from solveme.edc.org/mobiles. My own son loves to play on this website, and he'll spend a ton of time just solving equations. He's in 4th grade. He doesn't even know that he's solving equations because they're disguised as puzzles. So if you want to, it's a fun website. I encourage you to do it. Write down that website. That's more of like what we did for our warm-up. It is time to get cleaned up. That's it for today's video. Thanks for watching.